I'm Michael, and Dale's in the back getting mic'd and will join me shortly. We're both software engineers, contributors to Geode, and we are here today to talk to you about how to visualize your Geode metrics. So you might have, if you listened to earlier talks, you might have heard about Micrometer, and you might have heard about statistics and everything. So we're going to dive a little bit into those pieces. So viewing Geode metrics before now, there's you might have heard VSD. Basically, a custom viewing tool was needed to view these metrics, and you usually viewed them after the fact because they were stored local to where your Geode was running. So you'd have to go get them, and then you'd have to go get your reader, and then you'd load them up, and then you could finally see and look at what happened on our Geode system. You could also kind of look at them through like JMX. So I know I haven't done a whole lot of JMX before working on this, but it's another tool that you can go expose things. But it's there's a couple issues here. It's hard to see things live. It's all post. You can't. The doing analysis can be difficult for these various pieces. So let's talk about Micrometer and Geode then. So Micrometer is an open source metrics library. For those of you familiar with Java development, think of it like SLF for J, but for metrics. SLFJ is an abstraction for logging. It allows you to connect to these many logging things. Am I good? Better? Sorry, I lost my spot. So it's this open source metrics library. It's an abstraction to this. So the neat thing about this is that we can allow you to connect to any systems you might want to see these things. But the other important piece is you can now actually view these metrics as your system is running, so you can get a live view of what's happening. The other thing is there's extra details that these metrics can now get added to them. So think of them as like ways to change how you view it. So you could sort, you could filter, you can merge or separate out these different concepts. So let's talk a little bit about how this works in Geode. So the way we've decided to implement this through the open source community was in our Geode setup, we have these measurements. These are the things that we're actually trying to measure in the system. So think like memory consumption or CPU usage or other pieces, and we want to send those somewhere. And so what we do is we have this internal meter registry. Registry is this micrometer term. Oh, better, maybe? Okay. Eek. We have these measurements. They're added to our internal meter registry, and so this is the place where all the measurements are being sent to be recorded. And so this is really great. It allows us a central place for any Geode component to write measurements to, and then prepare them to be read out. So your new question might be, that's great. How do I get them out? They're all recorded in the Geode. So we have we're going to set up a little example here. We have our monitoring system and our Geode. So our monitoring system is external to Geode. This can be various different things. But the one thing we don't know is we don't know what monitoring system everyone uses. There's a whole bunch of different ones out there, and so what we provide is a meter registry implementation. This is an interface that the user can implement. It has two pieces, I guess, start and stop, essentially. How should I start this registry, and how should I stop it when you're all done with it? And so with that setup, we can now read the meters from our internal meter registry, go to your implementation, and ship them to your external monitoring system. So Micrometer provides a whole bunch of meter registry implementations that you can use. So some examples of that are like Datadog, Prometheus, Wavefront is a few examples of these various external metrics collection systems. And so using what's available in the docs and implementing the interface Geode provides you, you can connect to your system. So to get like a live view of your client, you would probably start with if you had your client, your locators, your servers, you can send them all to your external monitoring system, and then you can get a storage system and visualization. And once you get up there, you might finally be able to see something like pretty graphs and actually understand what's going on in your system. So, Dale, how do we record these measurements now?
Okay. Now that we can see how you can get measurements out to someplace you can visualize them, what measurements does Micrometer provide, and how does it provide them? A key idea in Micrometer is an instrument called a meter. A meter is an instrument that you use in your code to record measurements. And Geode uses a number of meters to record measurements and stores them in the repository, in the meter registry that Michael talked about. Did I go too far? I did. There we go. There's an example of instrumenting the code events received counter. We are incrementing our events received counter when more events come in. That's what it looks like in the code to instrument the code. Micrometer includes a number of types of meters. One is a counter that's designed for counting events. It can only go up. Counters never go down. They only count up. Another meter measures quantities that can go up or down, like the amount of JVM memory in use. And a third kind of meter actually records two things. It records the number of operations that have occurred, the total number of operations that have occurred, and the total amount of time they have accumulated. So those are some of the more common types of meters. There are others as well. Those are the kinds of meters. What information do you get in a meter? One thing you get is a name, which is a brief summary of the kind of information that the meter measures. There's also a full text description of what the meter measures. Every meter can include any number of tags, and we'll talk a lot more about tags over the next few slides. Of course, a meter records the most recently recorded value, the most recently measured value, and it also tells you what units those values are measured in, whether it be bytes or seconds or firkins per fortnight or whatever your favorite unit of measure is. Current Geode meters, we have a number of meters that tell you what's happening on your system, CPU usage, file usage, a number of meters that tell you what's going on in your Java processes, how long the process has been up, when it started, a number of meters that tell you how JVM memory is being used in your process, a number of meters that tell you what's going on in your garbage collection system, and some meters that tell you how many threads you have running, how many threads you have and what states they're all in. We also have a number specific to Geode, for example, the number of entries in your cache. Here's an example of JVM memory used. This is a small Geode cluster with 3 servers and a locator. This very noisy graph has 24 different meters. Every one of these meters tells you something about some kind of memory used somewhere in your Geode cluster. And underneath there are 24 different labels showing, 24 different legends showing you what each line represents. You can't read that, it's too noisy, there's too much information in there. Why are there 24 meters in this small cluster? To answer that question, we have to understand another key idea in Micrometer: tags. Tags, your monitoring system might call these dimensions, might call them labels. There are a number of other terms that people might use. A tag gives additional information beyond what kind of quantity is being measured. It gives additional information about exactly what's being measured, the scope of a measurement. Where was this memory measured? What kind of memory was being measured? A tag, other tags might tell you, for example, with garbage collection, what kind of thing triggered these garbage collections? What event triggered this garbage collection? The point of tags is to allow you to take all this massive information and focus on just the information you want by using the tags to filter the information that you're most interested in. Back to our slide. Every one of these, why are there 24 meters here? A meter is identified not only by its name, but by the combination of tags. And what that means is there are 24 combinations of tags on these meters. And we'll take a look at what that means. Here's one of those bits of legend. You can't read that either, so I'll blow it up a bit. One of the tags identifies what member this measurement was made on. This particular meter is measuring something about JVM memory on server 1. Another tag tells you that this is measuring the heap area of JVM memory. There are several areas. There's heap memory, there's non-heap memory. Within each area of memory, there are several other pools of memory, and the ID tag identifies which one this meter is measuring. This meter is measuring the Eden space. So with this combination of tags, we can see that this particular meter is measuring the Eden space in the heap area on server 1. And other meters are measuring other spaces in the heap, and others are measuring other spaces within non-heap, and other meters are measuring on the locator and on the other servers. And that's why there are 24 meters. So with this information, we can now select, we could say, for example, show me what's going on in the memory on server 1. We could say, show me what's going on in the memory, all the heap across all my system. What I'm going to do just arbitrarily is say, let's look at what's happening in Eden space on all of our members. And now we're back down to a much more tractable graph. This is showing what's happening on the locator and on the 3 servers in the Eden space memory. And which tags you use to select and filter your graph depends on what problem you're trying to solve and what question you're trying to answer. Every Geode meter comes with a set of tags that we add. One of the tags will tell you what member this measurement was made on. Another will tell you what's the ID of the cluster that this member is a part of. And a third will tell you what host is that member running on. So you can always slice and dice your data based on where it's running, what cluster it's part of, what member it's on. Also, when we add meters, we add specific tags most relevant to that kind of meter. For example, we have a Geode cache entries meter that measures the number of entries in your cache. It doesn't just tell you the number of entries in the cache. Each meter tells you the number of entries in a particular region. So we add a region tag that says this meter is measuring the number of entries in this region. And you can look at any region you like. Okay, and I think Michael's going to walk through a scenario showing how to use this information to see what's happening in a running system.
Let's dive in a little more on that Geode cache entry. So we ran a little scenario to generate some graphs and show you what you could try to understand with your system given a scenario. So we see here we've got a couple different lines. So there's actually 3 lines up there, and at the very bottom, it's a little hard to see, but it says server 1, server 2, and server 3. And we can see there's some jumps and downs and then jumps up again. So let's walk through the scenario that we ran, and then we'll correlate it back to this graph. So earlier you might have heard about partition regions and redundancy. So our specific example is going to work through partition region redundancy 1. And so redundancy 1 means that in a given cluster, there are going to, every time I do a put, every time I put in an entry, there will be 2 copies of that spread out through the servers. So starting with a first put, we get we put in entry 1, it's spread out between 2 servers because there's only 2. So each one gets a copy. Same thing for 2, same thing for 3. So great, it's there. We then decide, I really could use a 3rd server. We need that 3rd server to help us out, to make life better. So we add that 3rd server in our scenario, and it pops up. And to reorganize the entries, we'll rebalance. So we tell it to rebalance these, which means some of our entries are going to shuffle, where where they're currently located. So they move around. So in this one, I kind of arbitrarily picked entry 1 and 2, and now you can see each server has 2 entries, and our 2 copies are distributed evenly between this. So that means that the number of entries in each server has actually gone down because we've spread them out across a bit. So we say, yeah, this is fine, it's going great and everything, and then because I'm niceness challenged, I then remove server 3, just disappears, it's gone. I don't know what happened to it. And so what happens in the system is the system will say, oh no, server's gone, I'm missing these entries, I no longer meet redundancy 1. And so a rebalance happens, and the rebalance brings back the 2 copies of entry 1 and entry 2. And so I go back, I'm like, yay, everything's recovered, I've got my redundancy 1 again, and then I go, oh, I finally figure out what happened to server 3. I'm going to bring it back online. I bring server 3 back. Server 3 comes back. We ask for a rebalance, and then we end up with our thing. So this is the scenario that we walk through to generate that graph. So let's keep this knowledge of this scenario and look back at our graph. So we can see that we start increasing. We're putting in entries, and we keep shoving them in there. We've set up our code to have like an upper limit of 300,000 entries. So that's the curve that you see up there as it's going to asymptote at 300K. And so we first see that first dip, and that's when we started server 3. So that dip actually means that the number of entries in each region have decreased. So you can also see kind of the colors on there a little bit that server 3 is now popped up. So it's great. Everything came down. I've spread out my entries, and I'm still putting in more entries. So there's a curve, but now it's a different curve because the total number of entries will be less than 300K in each server. So then we stop server 3, and we see that jump. We see it jump right back up because it's immediately rebalanced. And the color goes back to the original color. You can see that. And then once again, we start server 3, and it goes back to our 2/3 line. So there's this really neat like live view you can see of this data flowing across the screen. In this case, Grafana is what we were using to capture this. So the neat thing about all of this is now that I've done it for one particular set of meters. So this was 4 specific meters watching a partition region just for entries. We can start to correlate this with potentially other pieces. So on the top is the entries that we were just looking at, and on the bottom is actually the CPU usage. And we can see that there's actually spikes on the CPU usage that correlate to those rebalances. And so this neat way of now being able to understand what's going on in your system closer to now. So together with all these pieces, you could start putting together dashboards, which then, depending on your team and what you're looking to accomplish with capturing these metrics, you can display them, you could set up alerts, you can watch them. So what do we do now, Dale?
Well, that depends on you. This is what we have so far. What we'd like from you is give this a try. Take Geode metrics, take these meters, add a meter registry that can publish to an external monitoring system of your choice. Make a dashboard or 2, see what it can tell you about the kinds of things you're wondering about, like if you do a lot of functions, where does your memory go? This might be very helpful to those of you who are understanding what's the right capacity. Try some experiments and use this information to help you see, for example, what's happening to your memory. Where's the memory going? Where's the memory being used? What things use memory and what things don't? So try that. Send it out to a monitoring system of your choice. Let us know what you like about this and what information you need that we don't have. So that's what we'd like from you is try it out and let us know what could help you. Thank you.
We do have time for questions. Right here.
So obviously you break out events per region and memory usage per region, do you also break out like processing time or CPU usage in a metric so I can see per region which one of my region is being the bad one, you know?
No. What we count per region right now is the number of entries per region. We don't show the memory per region. We looked into that, and for now, it turns out that's a very expensive operation to count when you add an entry. Figuring out how much memory that entry represents is a fairly expensive operation. We don't want to do that as a routine part of measurements. So we don't have that right now. We don't have memory broken out by region. Memory is broken out by what server it's on, what area of memory it is, and what space within that. Region for now is we tell you how many entries there are in each region.
Hi, that was a good presentation. So you said like you want to record those metrics as part of your code, right? Does it have any performance implications?
Yes, and we are measuring that very carefully with Helena and Jake watching over our shoulders as we do this. Every time we add a measurement, we can see the impact on the benchmarks. And in fact, some of this has helped us to improve the learning how Micrometer keeps its performance so high has helped us to adjust some of the other parts of Geode statistics to make that performance even higher. So the people who wrote Micrometer were very careful about thread safety and performance. And one of our key goals, Michael, I'm on the observability team in Geode. Michael was, for an unreasonably brief time, part of that team. And one of the things we care very much about is not impacting performance. So when we see an impact on performance, we'll figure out what to do about it. We haven't seen that yet.
As an interesting side note to that, we did find some place where we actually forgot to close some of the meters when the cache closed, and we actually got dinged by some performance team members that said your heap just kept going up because we didn't clean up. So we were very acutely aware of these.
Okay, and also like, do you have any levels that can be set? For example, if I want to broadcast the metrics as part of my code, can I switch off, switch on externally without making a change of code?
Not individual metrics, but one of the things you can do is you can choose not to publish the metrics at all. And if you don't publish the metrics, it's very, very fast. Collecting the metrics has very, very minimal impact on performance. Publishing them, if there's a performance impact, that's like, so you get all or nothing right now. We don't currently have configurable which metrics you want to see. One of the things Micrometer does, though, is remember that Geode itself doesn't publish any of the metrics. It stores them, and you can publish them. When you configure your registry, you can configure it to turn certain meters into a no-op and publish only the ones that you care about. So only the ones that you care about will have that publishing impact, and the ones that you don't care about will act as no-ops and be very, very fast.
See, there was one here in the front row, right there.
So your presentation was on the open source Geode. Is it any different if for the commercial implementation of Gemfire and Pivotal Cloud Cache?
So it will come up to those commercial implementations to decide what to do with this. I don't think I'm really equipped to speak to what they're doing, as that's the commercial.
We're currently integrating these with Pivotal Cloud Cache.
Okay, it's not there yet in the current Geo version.
That's correct.
Okay.
Anybody else? All right. Thank you, gentlemen.